All right, at least let me set that up and then we'll go through it. Your answer should be, oh, where do I have it? I got 861.2407. Okay, so if you got that, you're good, and anything you can do from there is fine. But, so you should take now, I don't memorize like the formula like a squared plus b squared, any of that. I just know if I got side angle side, in this case here, BD squared is going to equal the side 720.51 squared plus 411.11 squared minus 2 times 720.51 times, what is it, 411.11 cosine 95.19. And when we are done, or you're done, BD equals 861.2407. So that would be 861.2407. Now we do eventually have to find that AC length because it is one of the things they ask for. But you cannot really solve this unless you draw in an extra line somewhere. Okay, if you just get just the information, the picture they have given, you're going to get stuck. All right, from here, we can find out this angle. We can find out that angle because you're just solving a triangle. And then this is going to be 90 minus this angle to get here, 90 minus this angle to get here. Now, this angle is 95 degrees, so it does take out the possibility of getting, using the law of sines and getting it incorrect because of an obtuse angle. But I'm still going to go for the smallest angle just because out of habit, which would be angle CBD. And so using this triangle here, okay, I'm going to use the law of sines, and I'm going to state the sine of, I'm going to call it angle CBD, CBD, equal over 411.11 equals the sine of 95.19 over 861.2407. All right, so angle CBD up there. Now 4 decimal places. On there. And Nathan, you got it, or?
I think so.
What do you got?
28.38 degrees.
You gotta go 4 decimal places. Here's what's gonna happen. You only use 2 decimal places and you keep doing the work with 2, that your round off error will become too great and you'll end up missing the problem in the end. So it should be, I got 28.3847. So we want 28.3847. Okay, degrees. And now you got that plus 95.19 equals this angle down there. Or you take 90 minus 28.34, which is 61.6153. And now, depending on how you do things, if you do the law of sines, if you do 90 minus, you might be off by a 10,000ths at the end, but that's okay. What do I got? 56.4253. Is that right here? 56.4253. And then this one here is going to be, I got 33.57. Whoops, 5747. Which is, am I good there? Okay. For now. All right, now you got enough to finish it. You got enough to finish it. You just got to pick one of the sides to find. And let me find, I'm just going to find, I'm going to call X AB. I'm going to find that one. And so now you got to shift your attention to the triangle, the opposite triangle here. And then so sine of 33.5747 over x equals, I know sine of 84.81 over 861.2407. And round this, since this is one of your final answer, you can round this one to 2 decimal places. Okay. All right, anybody got it? Jake, what do you got?
Hold on, which one was that?
This A, B,
478.2472.
okay, and then this one can be rounded off to 478.25. All right, Cooper, you got AD there on the bottom?
Yeah.
What do you get? Yeah.
760.82.
760.82. Now, we got to get this dotted line. Well, once you have this, you got this right triangle, 760.82, 411.11, and then you got a right triangle. You use Pythagorean theorem. Okay, for that last one. Now, you might want to keep this out to 4 decimal places until you get that answer. You should be fine. Now, check the answers on the back page. I know the first one is right, 478.25. What's the AD listed? 76.82. All right, so now remember, you're allowed within 1/100th, which means you can have 478.24 or 478.26. Those would be okay. All right, and then same thing with the 760.82. All right, so I just at least wanted to give you that or go through that so you can have an idea what's going on there. So, and then what is that, 554?
For which one?
For AC.
For AC, 864.
864, my eyes going back.
Yeah.
All right, so sometimes you gotta, as they say, think outside the box. Try and draw in a line, that's always always a good idea for there. All right, number 10, from the homework. Were you able to get that right? All right, you got it right, that's good. Let me just kind of give you a quick rundown of what's going on here, and then give you a little bit of an idea. Okay, if you read the problem correctly, to arrive on schedule, you need to fly a bearing of 7 south, 75 degrees west, which would be the blue vector, and average 600 miles per hour. So when we're done, we want to average that. But a 70-mile-per-hour wind is blowing from the northwest. Well, those of you who are meteorologists know that's hurricane force wind. You're probably not going to be flying in it, but we got to do some math problems, so we're going to create some wind. Compute the speed and bearing the pilot will need to use in order to maintain the desired course and still maintain an average of 600 miles per hour. So basically, I want to end up here. Well, if the pilot actually aims there, will he end up there or she end up there? No, because the wind will push the plane to this path right there. So it's like, I equate it like when you were a little kid and you were like throwing a wiffle ball or something into the wind, you threw it this way and the wind pushed it over there. So if you wanted to go there to Ryan, I had to throw over here and then the wind would push it. So which way does this plane have to aim? Because if it aims right there, it's not going to end up there. Okay? So it actually has to aim somewhere over here. And then the wind will push it. Well, here's basically what you need to do is take our vector and figure out how we'll push it. And so I'm going to flip and one more. Make it go the opposite direction. So start it there, make it go the opposite direction. That tells you where to aim. You can do that. So I'm going to get this out of the way because that's not the path we want to travel. And if this is U, okay. Now V would be a degree of 315. You can keep it as 315, or what would be, if I flip it, make it go the opposite way, what would be the degree of that one? It would be not 315, but 315 minus 180, which is, I think, 135. So this is V. So you got two options. You can now do U plus negative V, but that's the same as U minus V. So some of you might have just subtracted the two vectors and you were fine. If you looked at my work, I put in 135 here, which means I did negative V. Okay. If you kept it as 315, you would need to take the U values minus the V values in terms of that. So that's a little bit of what's going on there. So if you have to account for something, you need to, use the wind to push you where you want to end up being. Any other questions on 1 through 9? You got to know these for the test. Okay, make sure you're good on those. Make sure you got the same, the format of the answer is correct. All right, I did go over everything. We will test on Monday. Okay, we're going to finish 7.5 today. We're going to do 7.6, and then we'll review, and then we'll test on Monday. All right, let's go 7.5. Maggie Purdy, you're on section 7.6 already. They're doing some polar graphs. Is that what you're doing there on the bottom?
No.
No? Oh, we'll do those tomorrow, or no, we'll do those Wednesday. I'll show you how to do them on the calculator. I'm not kidding. All right, dot product for a position vector V1, V2, and W1, W2. The dot product is denoted. Now make sure you copy down. I don't have it on there for you. This is how you find it. You just multiply the kind of what you would consider the x coordinates together, add, multiply, and then multiply what you would consider the y coordinates, and then add them together. It's not a vector, it's a number. 10, 12, negative 8, okay, 17. It's going to come into play, though, dealing with the angle between two vectors. All right, so find the dot product. All right, for this one here. So 2, negative 3, and 3, 4. So the dot product, V dot W equals 2 times 3 plus negative 3 times 4. 6 plus negative 12, negative 6. Okay, that's going to be your dot product. Sometimes I can give you a position vector, or it can be an IJ form. Remember, they're interchangeable. If you want to, if it's an IJ form, you can convert it to a position vector. You don't have to. But that would be the position vector negative 3, 5. W would be 2, 3. And then we would just do V dot W is negative 3 times 2 plus 5 times 3, and I get negative 6 plus 15, positive 9. All right, we're going to obviously do more than just find the dot product. Okay, here's the main way we're going to use it and how it comes up is finding the angle between two vectors. Now, if you go through the law of cosines, and there's a whole bunch of steps here, we're going to end up with the formula you see at the bottom. It's in your book if you really want to look it up. I think I just have on your paper, let the angle be between 0 and 180. And that's going to be between two vectors. Okay. Then here's what's going to happen. Then the dot product is going to be equivalent to the magnitude of V times the magnitude of W times the cosine of theta. And if you rearrange things, the cosine of the angle is the dot product divided by the magnitude. So that's kind of the main thing here. I'm going to write this over here because I want to refer back to it here in a little bit. So the dot product equals the magnitude of V times the magnitude of W times cosine of theta. All right, now I think I screwed up. Make those 2, 3, and negative 3, 4. I think I got them incorrect on yours. Because I wanted to match the picture, and I think I put a negative in the wrong spot or something. All right, so you have the vector. You can see the vector 2, 3. You can see the vector negative 3, 4. It's going to find, because if you look at it, you can say, well, there's really two angles there. It's always going to find the angle between 0 and 180. Okay, the smaller angle. And so in this case here, we're going to find that angle. All right, make a guess. Let's see how good of a guesser you are. Faye Burns, what do you think that angle is?
Like 75.
75. All right, well, let's see what it is. So we're going to use that formula cosine of theta equals the dot product over the magnitudes. And so cosine of theta equals, what do I get for the dot product? 2 times negative 3 plus 3 times 4. The magnitude is going to be the square root of 2 squared plus 3 squared. And the magnitude of W is going to be negative 3 squared plus 4 squared. Negative 6 plus 12 gives me 6 over square root of 13. That's going to just be 5. So I can make this 5 square root of 13. It's not always going to work out to be a whole number, but if it does, it's a little bit nicer. So you get 5 square root of 13. All right, use your calculator, type it in. Just, you might need to put parentheses in the denominator, I'm not sure. I don't know which calculator you have. We'll see how close Peyton is at guessing. Inverse cosine. Inverse. Whoops, hold on. 6 divided by, now mine doesn't do the little fraction thing, so I gotta make sure I put the denominator in parentheses. And I got 70.56. So not bad. 70.56 degrees. All right, find the angle between those two vectors. See what you come up with. Compare it with somebody near you. I'm just gonna rewrite these in standard form. And so cosine of theta is the dot product divided by the magnitudes. And -4 times 5 plus 8. All right, final answer. Lucci, your final answer?
Almost.
Almost. Almost. You get the fancy factor there. Yeah, I'm gonna tell you what it is.
I'm so excited about late start.
I got there.
Well, literally, I don't have to be here until 10. So I literally don't have to be here.
How'd you get there?
And then we have lunch right now. And then, I don't need to be back here till like 1:30. I literally here from 10 to 12. And then 1:30 to 2:30.
All right, I don't know how you got there. Adam, let's see if you can figure it out.
I got 127.9.
All right, 127.9. I'm gonna go 87. But that's fine. You had the right answer. 127.87. I forgot to say the nearest 100. Now, I didn't ask you to draw it out. Only reason I drew that out is so I had a visual image of should it be acute, should it be obtuse? You know, what's the angle going to be between them? All right, don't turn it over just yet. I want you to think here. All right. Vectors can be parallel. Give me two vectors that are parallel. What would that look? What would they? Give me two position vectors of parallel. What would that look like? Okay. So I want parallel vectors. So this is the vector 3, 2, right? Can we agree on that? Maybe. So what would a vector parallel to that look like?
6-4.
It's 6, 4. So 6, 4, 4, 5, 6, 1, 2, and then I'll go red. So if I go 6, 4, it's going to follow that same path. Okay. Now, are they the same vectors? No, because they're different what? Lengths, but they have the same direction. So how many different parallel vectors can we have? You can have infinite. You can have infinite vectors, okay, that are parallel on there. But you're going to say, well, they're not the same, even though they lie on top of, one lies on top of the other. They're not the same because one is 3, 2, and the other we'll call W is 6, 4. So now flip it over. Now flip it over. Okay. And here's why. How do you create it on that same angle? Okay, you just multiply the original one by a constant. If you multiply it by a constant, what he did was he doubled both the 3 and the 2 and made it 6, 4. Well, if you multiply it by 3, or if you multiply it by a half, or even -2, it works. So two vectors V and W are parallel if there is a non-zero scalar so that V equals C times V. I think that should be W. That's what I think. I'm going to make it a W. Okay. The angle between parallel vectors is either 0 or 180 degrees. So V and W are parallel only if, okay, this is true. Now I want you to think about that. So the angle is going to be 0 or 180 degrees. The cosine of 0 is 1, the cosine, that's a 0. The cosine of 180 is -1. Just remember your unit circle. So basically, if you have two vectors that are parallel, this becomes a 1 or this becomes a -1. So basically, that whole thing just boils down to plus or minus V over W. Now, if this is a scalar multiple, okay, you also get this second piece. So this would go under number 2 there. V1 over W1 is going to be equivalent to V2 over W2. And now what vector did we use? We had V was, in the previous slide, we said V was 3, 2, and then we made W, Jacob said it was 6, 4. So all you do is you take the first one, it becomes 3 over 6 equals 2 over 4. I mean, you can set up a proportion. But just the main thing is it a multiple? If you find it as a multiple, it's got to be parallel. Okay, for that. And I think that's the easiest way. So determine whether vectors V, which is 2I minus 3J, and W, which is -4I plus 6J, are parallel. Main thing is one a multiple of the other. And there's a lot of other avenues you can take, but that's the easiest one. So, and it might help, not that you have to, but this would be 2, -3. W is -4, 6. So that means W is equal to -2 times vector V. And so therefore, they are parallel. Parallel. All right, using this, let's go back to this right here. If two angles are perpendicular, two vectors, let me say two vectors are perpendicular. What's the angle between them? It's got to be what? 90, correct? What is the cosine of 90 degrees? What's the cosine of 90 degrees? Unit circle, what's the x value there? 0. So what does this whole thing boil down to if you have a 90-degree angle there? 0. So that means the dot product is going to be 0. Now for vectors, they give it a fancy name. They don't say perpendicular, they say orthogonal. Okay, but it just means perpendicular. So two vectors, V and W, are orthogonal if and only if their dot product equals 0. So hopefully that makes sense because this is going to be a 90-degree angle. And cosine of 90 is 0, so that basically wipes out everything there. All right, so now this one's just a little bit different. It says find a scalar C so that the vectors V and W are orthogonal. All right, so it's not asking you whether they are, it's just create the situation where they are. So V is going to be 3, 2, and then W is going to be just 4C. If you're going to write it in position form, just put a C there. We don't know what that value is at this point. All right. If they're orthogonal, it's got to equal 0. So say 3 times 4 plus 2 times C equals 0. Solve for C. And then I get 2C equals -12. I get C equals -6. All right, so parallel, okay, 180 or 0 degrees, perpendicular 90 degrees, and then the dot product is 0. Okay, page 753 here. These are easy ones. Anybody find out if Madison's on the way home yet? Or is she still stuck in Florida?
The doggies are really good.